watching Xenofeed, News of the Outworld. Have you ever wondered if the reality you perceive is actually real? Or are you just a digital avatar in a sophisticated computer simulation, unaware of the true nature of your existence? This may sound like a plot of a science fiction movie, but some philosophers and scientists have seriously proposed that we may be living in a simulation. Today, we will explore 10 scientific arguments that support this possibility and what they imply for our understanding of reality. 1. The simulation hypothesis. The simulation hypothesis is the idea that our physical reality is actually a computer-generated simulation, created by some advanced civilization for their own purposes. The hypothesis was popularized by the philosopher Nick Bostrom in his 2003 paper, Are You Living in a Computer Simulation? Bostrom argued that one of the following 3 propositions must be true. 1. All human-like civilizations in the universe go extinct before they develop the technological capacity to create simulated realities. 2. If any civilizations do reach this phase of technological maturity, none of them will bother to run simulations. Or 3. Advanced civilizations would have the ability to create many simulations, and that means there are far more simulated worlds than non-simulated ones. Bostrom based his argument on the assumption that if a civilization can create realistic simulations of their ancestors, they would create a large number of them, and each simulation would contain a large number of simulated beings. Therefore, the number of simulated beings would vastly outnumber the number of real beings, making it more likely that we are among the simulated ones. 2. The Fermi Paradox. The Fermi Paradox is the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of evidence for them. The paradox was named after the physicist Enrico Fermi, who famously asked, "Where is everybody? If there are billions of stars in the galaxy, and many of them have planets that could support life, why haven't we detected any signs of intelligent life in the universe?" One possible answer is that we are living in a simulation, and the simulation does not include any other civilizations. Perhaps the simulators are only interested in studying human history, or perhaps they want to isolate us from any external influences. 3. The fine-tuning problem. The fine-tuning problem is the observation that the physical constants and laws of nature seem to be finely tuned to allow for the existence of life and complexity in the universe. For example, if the gravitational constant was slightly different, stars and planets would not form, or if the nuclear force was slightly different, atoms and molecules would not exist. How can we explain this remarkable coincidence? One possible explanation is that we are living in a simulation, and the simulators have chosen the parameters of the simulation to create a universe that is conducive to life and complexity. Perhaps they want to observe how life evolves, or perhaps they want to create a universe that resembles their own. 4. The quantum measurement problem. The quantum measurement problem is the puzzle of how the quantum state of a system, which is described by a superposition of multiple possibilities, collapses into a single definite outcome when it is observed. For example, according to quantum mechanics, an electron can be in 2 places at once until someone measures its position and finds it in one place or the other. How does the act of observation determine the outcome? One possible explanation is that we are living in a simulation, and the simulation only computes the outcome of a quantum event when it is observed. Perhaps the simulators want to save computational resources, or perhaps they want to create a quantum indeterminacy that allows for free will and randomness. 5. The holographic principle. The holographic principle is the idea that the information content of a volume of space can be encoded on a lower dimensional boundary, such as a surface. For example, a hologram is a 2-dimensional surface that can project a 3-dimensional image. The principle was originally proposed to solve some paradoxes in black hole physics, but it has implications for the nature of reality as well. If the holographic principle is true, it means that our 3-dimensional reality is actually a projection of a 2-dimensional reality, and that the fundamental bits of information that make up the universe are not located in the space itself, but on its boundary. One possible explanation is that we are living in a simulation, and the simulation is encoded on a lower dimensional surface, such as a computer screen. Perhaps the simulators want to create a more efficient simulation, or perhaps they want to create a more realistic illusion. 6. The pixelation of spacetime. The pixelation of spacetime is the idea that the smallest units of space and time are discrete and finite, rather than continuous and infinite. This means that there is a limit to how small you can divide space and time, and that there is a minimum distance and a minimum duration that can be measured. This idea is supported by some theories of quantum gravity, such as loop quantum gravity and string theory, which suggest that space and time are composed of tiny loops or strings that have a finite size. If the pixelation of space-time is true, it means that our reality is not smooth and continuous, but grainy and discrete, like a digital image. One possible explanation is that we are living in a simulation, and the simulation has a finite resolution, like a computer screen. Perhaps the simulators want to avoid the mathematical difficulties of dealing with infinities, or perhaps they want to create a more manageable simulation. 7. The mathematical universe hypothesis. The mathematical universe hypothesis is the idea that our physical reality is not only described by mathematics, but is actually identical to mathematics. This means that everything that exists in the universe, from particles to planets, is a mathematical object or structure, and that the laws of nature are mathematical equations or rules. The hypothesis was proposed by the physicist Max Tegmark, who argued that mathematics is not a human invention, but a discovery of the ultimate nature of reality. If the mathematical universe hypothesis is true, it means that our reality is not physical, but abstract, like a computer program. One possible explanation is that we are living in a simulation, and the simulation is based on a mathematical algorithm, like a computer code. Perhaps the simulators want to create a more elegant and consistent simulation, or perhaps they want to create a more universal and objective simulation. 8. The information theoretic death. The information theoretic death is the idea that death is not the cessation of biological functions, but the irreversible loss of information. This means that a person is not dead when their heart stops beating, but when their brain is destroyed or their memories are erased. The idea is based on the assumption that consciousness is a form of information processing, and that information can be preserved or transferred to different substrates, such as computers or artificial brains. If the information theoretic death is true, it means that our reality is not defined by our physical bodies, but by our information content, like a computer file. One possible explanation is that we are living in a simulation, and the simulation can store or copy our information, like a computer backup. Perhaps the simulators want to create a more immortal and flexible simulation, or perhaps they want to create a more ethical and compassionate simulation. 9. The ancestor simulation argument. The ancestor simulation argument is the idea that we are living in a simulation that is specifically designed to recreate the history and culture of our ancestors. This means that the simulators are not some alien or future civilization, but our own descendants who want to study or experience their past. The argument is based on the assumption that our descendants will have the technological and ethical capability to create realistic and detailed simulations of their ancestors, and that they will have a scientific or historical interest in doing so. If the ancestor simulation argument is true, it means that our reality is not original, but a replica, like a historical reenactment. Perhaps the simulators want to learn more about their origins, or perhaps they want to empathize more with their ancestors. 10. The simulation escape argument. The simulation escape argument is the idea that we are living in a simulation that is not perfect, and that we can find glitches or loopholes that can allow us to escape or communicate with the simulators. This means that the simulators are not omnipotent or omniscient, and that their simulation is not flawless or complete. The argument is based on the assumption that our reality is not deterministic, and that there are some unpredictable or unexplainable phenomena that can reveal the nature of the simulation, such as quantum anomalies, paranormal events, or spiritual experiences. If the simulation escape argument is true, it means that our reality is not fixed, but mutable, like a video game. Perhaps the simulators want to create a more interactive and dynamic simulation. Are we real or simulated? Are we alone or watched? Are we free or controlled? Are we doomed or saved? These are the questions that may haunt us as we ponder the simulation hypothesis. Perhaps one day, we may find the answers. This is Xenofeed. If you enjoyed this video, leave your comments below and please remember to like, share and subscribe.